Today's topic is linear algebra. In linear algebra, most important topic is rank of a matrix. Why I stressed about the most important topic at the in the case of examination. Of course, the one question must from this topic as well. There are so many applications are there. First, if we want to know how many solutions are there for a system of equations, then this rank will decide. Okay, like a group of equations, if we are taking, then um, how many solutions it has depend on the rank. If rank of a matrix is equal to number of variables, see here, for example, if I take this, for example, x plus 3y plus z is equal to 5, and one more I am taking 2x plus y plus 3z is equal to 5, and here x minus y plus 2z is equal to 10. Here there are three system of equations we have, but if I calculate this, if I get the rank is equal to, this is the symbol of the rank, if I get rank is equal to 2, how many variables are there here? X, y, z. There are three variables are there, right? So number of variables are 3, correct? Here rank is not equal to number of variables. Then see here, there are three cases will be there: unique solution, infinite number of solutions, and no solution. There are three cases it will arise. Unique solution means rank of the matrix must be equal to number of variables, means rank if it is equal to 3. See, number of variables also equal to 3. Here rank is equal to number of variables, then you can say the system has unique solution. You won't get more values, x, y, z values, only one number you will get, not the same number. It may be x is equal to 2, y is equal to 3, z is equal to 5, like that it will come. Okay, and in the case of infinite number of solutions, if rank is less than number of variables, see here I took as the example, if rank is equal to 2, of course number of variables it may not change, 2 is less than 3 only, so the system has infinite number of solutions. When we will get the no solution, see, rank of the matrix A is not equal to rank of the augmented matrix. What is augmented matrix? See here, the matrix A I will take as 1, 3, 1, x coefficient, y coefficient, z coefficient, and one more 2, 1, 3, and 1 minus 1, 2. From third row I can write, this is the matrix A, augmented matrix. Here write the colon and write that RH is also this 5, 5, 10. We will consider this as my fourth column. Okay, first column, second, third, and fourth column. If you calculate rank for this is called augmented matrix. Then you can give the name for this is A colon B. This is augmented matrix, and this is rank. This is called the matrix A. If rank of A is not equal to rank of augmented matrix, then it doesn't have the solution, no solution. Okay, when we are going to do the problems, it will be more clear. But before learning anything, any topic, first we should know why we are learning, where we can apply. These are most important. Okay, that's what I want to discuss, the applications of the rank. This is one of the applications by seeing the system of equations. System of equations means, now I gave the example, it may be the combination of 3 equations or 4 equations or 5, like that. Okay, that is called the system of equations. So without calculating the solution procedure depend on the rank, you are going to conclusion, you are going to conclude that how many solutions that system has. unique solution when you will say if rank is equal to number of variables, and infinite number of solutions if rank is less than number of variables, and no solution rank of the matrix not equal to rank of augmented matrix. These three are the points. Okay, next one more application is there, whether the system we will write the matrix like this now, like 1 2 3 4 5 6 7 8 9. Okay, how I will write this matrix? What is the before story of this? Before story is this: x plus 4y plus 7 into z is equal to 0. Again, 2x plus 5y plus 8 into z is equal to 0. And one more, 3x plus 6y plus 9 into z is equal to 0. What is the before story of this? Before story is it has some what I can say, that theoretical problem will be there. That problem, theoretical information, we are going to convert in terms of the equations. Okay, that is called the modeling. Correct. So that before story is theoretical model. That means now I want to know that whether these two equations are independent equations or dependent equations. Okay, if I want to know, this rank will help us. Okay, these two equations, nothing but first row and second row only na. I want to know that whether these two rows are linearly dependent or independent. Then what I will do, I will calculate the row. Row is nothing but rank. The symbol is called the row. That is nothing but rank. If rank is equal to number of rows, how many rows are there? 3 rows are there. If rank also equal to 3, number of rows is automatically, we know that that is 3. If rank is equal to number of rows, then you can say that these rows are linearly independent rows. Okay, rows, linearly independent rows. If I want to check that independent dependent between the columns, the same logic apply. Find out the rank, then compare with the number of columns. If rank is equal to number of columns, then you can say that all that columns are linearly independent. They doesn't have any relation between those columns. Okay, that is the second application of the rank. And third application is whether the matrix has inverse or not. How to find out? Sometimes the big numericals will be there. We may doesn't know. Again, one more problem we have to do to find out the inverse. Okay, already if I know the row rank of that particular matrix, then depend on that I can judge whether the matrix has inverse or not. If rank is equal to order of the matrix, see here, what is the order? Order is nothing but number of rows by number of columns, right? 3 rows and 3 columns. So order rank is, if rank is equal to 3, here order of the matrix also equal to 3, 3 by 3. It will work only for the square matrix. So 3 by 3, 2 by 2, 4 by 4 we will consider as 3 or 4, like that. If it is 4 by 4, we will consider as the 4. If rank is equal to 4 and order also 4, then you can say that yes, the matrix has the inverse. This is the invertibility of your matrix. So we can say that determinant also not equal to 0 if that condition satisfied. And few more, not so many applications are there, and a few more I want to discuss that. And we can apply rank in the machine learning. We are applying that. Even graph theory, in the graph theory also we will find out, depend on the rank only, how many number of connected components, otherwise existence of subgraphs, all that information will come to know that one. And main, I like this application very much, that is whether the system has the control or not, whether I can control that system, otherwise I can only observe the system. That will decide by the rank. This is control theory. In control theory this concept will help. Okay, I can say that, see, if rank is equal to order of the matrix, then you can say that the system is controllable. Otherwise, if rank is not equal to order of the matrix, then you can say that system we can observe, we cannot control. Okay, when the vehicle is moving from one place to another place, how it will move? We will apply some energy for that to move it, right? That we can convert in terms of the equations, that you can call it as linear time variant system, that is like state space form. For example, x of t is equal to a into x of t plus b into u of t. One more I can write, y of t is equal to c into x of t plus d into u of t. See, this is x of t is nothing but state vector, and A is state matrix, and this is B is called the input matrix. This is input matrix. U of t is input vector, okay, and y of t is output vector. This is output equation, output vector, and C is output matrix. Already I said x of t is nothing but state vector, and D is fixed forward matrix. And these all are that behind story of the matrix formation. And this is nothing but, if I frame this as the equation, for example, I can make that 2 by 2 matrix, 0 1 2 5, like that I can make it this as a 2 by 2 matrix by converting this into a matrix form. If I calculate rank for this, if rank is equal to 2, here see how many, what is the order of the matrix? 2 by 2 only, na? Rank is equal to 2, correct, na? If rank is equal to the order of the matrix, you can say that whatever the equations you are getting, the system is controllable. Okay, what is the controllable? It is possible to drive the state vector from any initial state to any desired final state within a finite time interval using an appropriate control input. See, in signal processing, the rank of a matrix is oftenly we are using to analyze and manipulate the signals, especially in the control of dimensionality reduction, noise reduction, and the data compression. We are going to use it. Of course, so many applications we discussed as on up to now. Now let we learn. I think all you people understood the application, so it is very important to know the procedure. Let me learn that 3 procedures. There are 3 procedures are there to find out the rank. You can follow anything, no issue. I feel that among all, echelon form is very friendly, and that's what in most of the syllabuses, it may be the engineering or BSc syllabus, they are adding only this echelon form. They are removing normal form as well as PAQ form. Okay, first I am going to teach you that echelon form. Very, very important. Echelon form. Yes, this is the question is, find the rank. Find the rank, right, of the following matrix by reducing into echelon form. I am not writing a total question. I am dictating slowly. If you want, kindly note down. Find the rank of the following matrix by reducing them to the echelon form. The first question is 1 2 1 0. Next is -2 4 3 0 and 1 0 2 8. This is the given problem. Okay, now solution I'm going to write. This is the solution now. See, anyhow you will copy this matrix again, right? 1 2 1 0. This is first row first column element minus 2. This is second row second column element, and 1 0 2 8 third row third column element. This is diagonal elements I am making like this. Okay, and I want to make that below the diagonal elements I have to make the 0. Correct now? That is only in echelon form. I said that echelon form conditions what? We have to use only row operations. That is the first one. Only row operations make it. And after that, second one, for easy to understand, to remember, I am using this statement. Here the diagonal elements are there. Na? Below the diagonal elements make 0. After that, the third step is this diagonal elements also you have to make 1. That's all. That is only echelon form. Now see, please follow the same procedure. Here minus 2 is there. Below the diagonal element I have to make 0. So this minus 2 I want to make this as the 0. Okay. For that, let me do this. This is R1 is the first row. This is the second row. This is the third row. Then R2 implies, I am expecting change here. R2 implies, generally write this, R2 minus R1. Without thinking, write down. R2 element what? Minus 2 here, nama, first element, minus 2. That write as the coefficient for R1. R1 element what? 1. That right here. Automatically this place will become 0. Okay. So this, how can I write it? R2 minus into minus plus. So 2 into R1. Correct? R2 plus 2 into R1. Now see, minus 2 plus 2 into 1. What it will happen? It is 0 only, na? 1, 2, 1, 0. If I do this operation, it will become here 0. Then this will be 8. And 5, 0. Later I will explain to you how to use scientific calculator to solve this. Okay, first you learn the concept, then we will discuss about that. Second row is done, and below the diagonal elements I have to make 0 means another 2 elements are there. So let me take this also I have to make 0, this also I have to make 0. Then here see, this is 1, right? In the first step, please take help from R1 only. R3 implies R3 minus R1, write down. R3 element 1, R1 element 1. We know 1 minus 1, 0 only, na? So 1 minus 1, 0. 0 minus 2 is minus 2. 2 minus 1 is 1. 8 minus 0 is 8. See here what it happened. This is the diagonal elements 1, 8, 1, and below these two became 0. Now the next is one more element pending is there, na? Let me shade this. This I want to make the 0. For that, this you can call it as step 1. And to make this is 0 minus 2, this will be, you can come under the step 2. Okay. When you are making this as 0, in the step 2, you have to take help from R2 only. If you take help from R1, this place will disturb due to that reason. Okay. Then change I am expecting in R3. R3 implies R3 minus R2. Commonly write down for all the problems like this. Then you observe that what is the non-zero element here. This is my aim, right, to make the 0. This is the R3 element only, na? Third row element. This R3 element, write for R2 minus 2. And R2 element is 8. Please write for this. Okay. How can you write this? 8 R3 minus into minus plus 2 into R2. Okay. If you do this, our matrix will convert 1 2 1 0 0 8 5 0 0 8 into R3 8 into 2 16 2 into 8, 16. If I am adding, obviously it will be 0. Then here I am going to get 18. Then I am going to get the 64. Okay. This is in the echelon form. See the diagonal elements how they are. 1, 8, 18 is there, and below the diagonal elements are 0 only. I can say this is an echelon form. But perfect echelon form means these diagonal elements, otherwise I can say that non-zero elements. This is 0, non-zero element here only in a second row. This you have to make it as 1. And here see, in the third row 2 zeros are there, and this you have to make it as 1. For that what you have to do, I am going to clear this. Each row, whatever the non-zero element is there, please divide with that. That's all. That is only the last step in this problem. See here, I'll do that. R1, already 1 is there, not required to disturb. R2 implies R2 by 8, and R3 implies R3 by 18. That's all. See how our matrix will be convert. 1, 2, 1, 0, 0, 1, 5 by 8, it is 0. Then again 0, 0, 18 by 8 and 64 by 18. This is the last. This is everything in terms of the echelon form. You can cancel 64 by 18 is there. If you cancel, it will be 32 by 9. You can leave like that also. You can write the conclusion. Yes, this is in echelon form. Diagonal elements all are 1 only, and below the elements are zeros. And you may get here zeros, no issue. Diagonal elements, there is no condition like that. It has to be 1. It may be the 1, it may be the 0. No issue for us. Okay. So this is in echelon form. And what is rank? Number of non-zero rows. 1, 2, 3. How many rows are there? 3 rows are there. 3 non-zero rows are there. So rank is equal to 3 for this problem. If this problem is related to our any control theory or like that. And what is the order of the matrix? Order of the matrix is, what is that? 3 rows, 4 columns are there. 3 by 4. You cannot equate with rank is to order. Why? Because this is rectangular matrix, not the square matrix. Okay. And you can find out that whether rows are independent or not. That you can say. Number of rows. How many rows are there in this? 3 rows are there. Rank is equal to 3. Then you can say that rows are independent, but columns are dependent on each other. Correct, na? Because number of columns equal to 4. Rank is equal to 3. We got it. So it is called columns are dependent, rows are independent to each other. That is about echelon form. We will take one more problem also to convert into echelon form, because this is important. Let me do few more on this. The next second problem is matrix. Find the rank of the following matrix. Find the rank of the following matrix by reducing them to echelon form. Here, this problem also I am taking 3 by 4 matrix. 1, 2, 3, 2. Again 2, 3, 5, 1. And again 1, 3, 4 and 5. Here see 3 rows and 4 columns. Then to check that we need to find rank. Okay. So solution will start here. Now see, diagonal elements. I am making this first row, first column, second row, second column, third row, third column. Then below the diagonal elements I have to make zeros. What is my aim in the first step? See, my aim is this, correct na? This I have to make 0, this I have to make 0. This is my first target. So this is my step 1. In the step 1, please take help from R1, correct na? So R2 implies, because this 2 is in R2, R2 implies R2 minus R1. Commonly write down R2 element is row 2. Write the coefficient for R1. R1 element is 1. As it is, you can keep it. Then R3 implies, same thing write down, R3 minus R1. Okay. So now see, R3 element is here 1, here also 1. Same 1, 1 only now. That's what I'm not writing anything. Now, if I do this calculation, see how it will change. 1, 2, 3, 2, right? R2 minus 2 R1. R2 elements are here. Multiply with the 2 all the elements of R1. Then automatically the answer will become like this: 0, minus 1, minus 1, minus 3. And if you do R3 minus R1, then it will be 0, 1, 1, 3. It will change. Okay. Now, see here, and again I'll go for this diagonal elements. Diagonal elements are here, and what is my target in the step 2? I have to make this place is 0, correct? So for that, see here, step 2. In the step 2, you have to take the help from R2 only. Change where we are expecting in R3. Change where you are expecting right here. R3 implies R3 minus R2. This is common only. Okay, ma? Now, R3 element is 1. Please write as a coefficient for R2. R2 element is what? Minus 1. Write coefficient for R3. Okay. Minus R3 plus R2. Like this you can write. Actually, generally we will follow this method if other elements are there. But this problem, the beauty of this problem is these two are just opposite signs. Okay. Without thinking this, blindly you can make it R3 implies R3 plus R2. Either you can do this or you can do this. Both are same only. Okay. So automatically 1, 2, 3, 2, 0, minus 1, minus 1, minus 3. Third row, all the elements became 0. Okay now. Then see here, this is the good example. Diagonal elements, we got 1, minus 1, 0. That's what I said, that in the diagonal elements, there is not compulsory. It has to be 1. Either 1 or 0. No issue for us. Okay. You can call it as a echelon form only. But a small change is required. That is minus 1 is here. But we are expecting 1, right? Diagonal elements either 1 or 0. So let me multiply R2 with minus symbol. Okay. Then 1, 2, 3, 2, 0, 1, 1, 3, 0, 0, 0, 0. Correct? This is in echelon form. This is in echelon form. You can call one more name is row reduced echelon form. How many number of non-zero rows are there? See here, last row, all elements are zeros only. Then you can call this row is 0th row. And non-zero rows are 2 are there. So you can say that rank is equal to 2. This is about this problem. And if you want to check that control whether their rows are dependent and independent, you can say that here rows are equal to 3, which is not equal to rank, and columns are equal to 4, which is not equal to rank. So you can say that this in the system, in this problem, rows and columns are dependent on each other. If they are equal, rank equal to number of rows and number of rows, then you can say rows are independent. But here, rank is not equal to number of rows and number of columns also, right? And even you can say, if it is a square matrix, then you can compare with the order, but this is the rectangular matrix. That's what we are not comparing. Let me see that maybe third problem we may get as the square matrix. If we get, we will see. No, third matrix also, it is not square matrix, it is the rectangular matrix only. But of course that point anyhow we understood na. I want to take this example. I will tell you why I am taking this, because this is important. Please write the same as it is. Find out rank to the following matrix by reducing into echelon form. Okay, that is anyhow it is there, and for me it is boring to write the theoretical anything, so directly I'll go to that problem only. I am dictating again the question. Find the rank of the following matrices by reducing them to echelon form. Okay, now this is not compulsory. Here see, here 0 is there. If this element is 1, our calculation is easy. Okay, I cannot say that this may not be the 0. It may be the 0, no issue, we can do. But in this place, if we have either numerical or 1, our calculation part will be easy for us. Okay, and now see, what are the diagonal elements? These are the diagonal elements, and our target is below the elements I have to make the 0. So for my calculation, to make my calculation easy, let me interchange the rows. I said that when we are calculating, when we are doing the elementary transformations, we can do 3. What we can do? We can interchange any row, any column also we can interchange the positions. Otherwise one more also there that you can do. And one more is, you can multiply with any numerical to the row, otherwise to the column also you can multiply. And one more is, you can add 2 rows, you can subtract 2 rows, and you can multiply with one row and you can add to another row. That also you can do. Okay, only these 3 only you can apply it. Now coming to this one, I'm going to interchange it. See, I will do either I can interchange first row and second row, or first row and third row. Okay, why? Because I don't want 0 here, I want the numerical, but I prefer this 0 let it be in the third row. Okay, so I prefer to do this R1 to R3. I am interchanging that. 4, 8, 13, 12. Then again 2, 3, 5, 4. 0, 2, 3, 4. This is I interchanged. Then again I am taking diagonal elements. For my convenience, I am applying the diagonal elements here. And what is my target now? Below the diagonal element I have to make 0. Luckily this is 0, right? So only one operation is enough for us. Okay, so this is in the R2. R2 implies R2, commonly write down R2 minus R1. This step 1, this is compulsory. Now R2 element what? 2 is there. Okay, write for R1. R1 element what? 4 is there. Why? Because 4 into 2 8, 2 into 4 8. This I want to make the 0. So this is the alternate for that. That's what I took this example. I want to tell this because before problems we got one coefficient as 1, right? But this is a perfect example, and I want to tell that if in this place 0 is there, means the calculation part little bit difficult for us, so we have to make the interchange. That's what I chose it this. 4 into R2 minus 2 into R1. We can do that. Now calculation part, right, 4, 8, 13, 12. Then here this, if I make 8 0, and what I said, 4 R2, 4 3s are 12, right? And 2 8s are 16. 4 into R2 minus 2 into R1. 4 3s are 12. See, if you want to do that rough work, better to do here. You may not get any confused for that. I prefer to do like this. Okay, ma'am. 4 2s are 8, 4 3s are 12, 4 5s are 20, 4 4s are 16. This is easy for us. Then 2 into R1, right? 2 4s are 8, 2 8s are 16, 2 13s are 26, 2 12s are 24. Then I am subtracting, right? So 8 minus 8 0, 12 minus 16 4 only, nama, minus 4. Here I will make it as minus 4. Then 20 minus 26, again here minus 6. Then 16 minus 24, it will be minus 8. 16 correct only, na? Minus 8. And here 0 2 3 4, this is okay. So again diagonal elements will make like this. This is the diagonal elements, and we have to make this place as 0. But before that, any problem if you are doing now, any common multiples are there, please divide with that concerned number. Then our problem will be easy for us. So why I mentioned that, R2, if you see, R2 we have the common multiple, na? R2 by minus 2. I don't want to see that minus also. So let me do that minus 2. Okay. With minus 2 means then it will be more clear for us. 4, 8, 13, 12. Then it will be 0. Minus 4 by minus 2 is 2 only, na? Minus 6 by 2 is 3 only, na? Minus 8 by minus 2 is 4. Now see. 0, 2, 3, 4. This is the diagonal element, and if you see that this element I have to make 0, but luckily if you see that R2 and R3 both are identical, so you can make that R3 implies R3 minus R2. Always you prefer 0 rows in the down. Then 4, 8, 13, 12. 0 2 3 4, and this is 0 0 0 0. Now see here, 4 2 0, this is the diagonal element always A11 A22 A33. First row first column, second row second column, third row third column. See, all below the elements I got the 0. This is in echelon form only, but perfect echelon form we want, na? For that what we will do, perfect echelon form means diagonal elements we have to make. Okay, I want to clear this rough work. Yes, we have to divide with the concerned element, correct? So for that, R1 implies R1 by 4, R2 implies R2 by 2. That's all. Then automatically 4 by 4 is 1, 8 by 4 is 2, then 13 by 4, 12 by 4 is 3, and again 0, 2 by 2 is 1, 3 by 2 here, 4 by 2 is 2, and this is 0 0. See here, this is the all the diagonal elements are here. 1 0, either 1 and 0 acceptable. Below the diagonal elements are 0, so this you can solve. This is in echelon form. And what is the rank for this? Rank is number of non-zero rows. There are only 2 rows are there, and third row is the 0th row only, na? So rank is equal to 2. I hope you people are able to follow this echelon form system. Then we will learn the second method to find out the rank. Okay, what is that second method? Just repetition of echelon form. Okay, repetition of echelon form for the column also. We did for the row, right? Now we have to make for the column also. If we are touching the column, we can apply the column operations also. That is the difference between row reduced echelon form and normal form. In the echelon form, you can apply only row operations, whereas in the normal form, you can apply both row and column. And Row reduced echelon form is nothing but diagonal elements identify, and below the diagonal elements you have to make 0, and a normal form is nothing but your identity matrix. What is the identity matrix? You remember? Is nothing but diagonal elements are there na, that it has to be 1 and remaining all has to be 0. Okay, this is that 1 0 0 0 1 0 0 0 1. This is called the normal form. Here also I am telling one more thing. Diagonal elements, it may be 1, it may be 0. But if I am telling this, I'll make 0 here. If you tell, no, it is not acceptable. This, it has to be 1 only. Here it may be 0. Okay. In that case, what we will tell? 1 0 0 1. Second order identity matrix. Now this is I 2 by 2. This is the 0th column. Let we write. And this is the 0th row. Let we write. Like this we can write it. Okay. So just remember that normal form is nothing but we can use both row and column operations. Our aim is to convert into identity matrix. Automatically few elements will become 0. Don't worry. Easily we can identify our answer. Okay. That let we start one just we will do one problem, because echelon form is most important. Normal form, just you should know what is the normal form. That's enough. Right. Write that. Find the rank of the following matrices. Please write. I am lazy to write the theoretical, as you know. Please write that. Find the rank of the following matrices by reducing them to the normal form. By reducing them to the normal form. This is our matrix 2 1 3 1. This is 3 by 4. Order 3 rows and 4 columns. Okay. You have to convert into normal form. This is okay. Now, as we know, identify diagonal elements. Any problem, it may be echelon or normal form. Our aim is identify the diagonal elements. Then we will make below the diagonal elements are 0. First apply the echelon form. That's all. It will be the revision to you. That's all. Okay. Later I will tell you how to continue to the normal form. Okay. Now, as we know, step 1 is, this is R2 element na? R2 implies R2. Generally we will tell R2 minus R1 na? But before that I told one more also for you. What is that? We have to interchange the places. Correct. We have to interchange the places. Either R1 to R3, otherwise R2 to R3. You can do that. I will do R2 to R1, otherwise R3 to R1. R3 to R1 we will do. Why 0 if let it be last. Okay. R3 element I am writing 2 1 3 1 4 0 2 6 and 0 1 2 minus 2. This is okay. R3 double implies R1, interchanging of R1 and R3. Now see, I said you before starting only I told you, any cancellations are there, please make it that. Let your work will be simple. Then if I observe R2 is 2 multiple. R2 implies R2 by 2. Then 2 1 3 1 2 0 1 3 0 1 2 minus 2. Correct? This is proper for us now. And identify the diagonal elements. Make the below the diagonal elements are 0. So our aim is to make this 0. Correct? Then 2 minus 2 only na. R2 implies R2 minus R1 I can do. Then what it will happens? 2 1 3 1. 2 minus 2 is 0. 0 minus 1 is minus 1. 1 minus 3 is minus 2. 3 minus 1 is 2. Then 0 1 2 minus 2. Okay, so this already is 0. That's what I did not touch this. Again, identify the diagonal elements. These are the diagonal elements, and this I have to make 1. Okay, and one more beauty of this problem is R2 and R3 identical. Okay, so R3 implies, anyhow, if our target is to change anything in R3, you have to take help from R2 only. Don't touch R1. If you touch R1, this 0 will be disappear and it may convert as the numeric. Again, our story will repeat. Due to that, if you want the change in R3, take help from R2. If you are expecting change in R2, take help from R1. That's all. Okay, that hierarchy you have to maintain that. 2 1 3 1, 0 minus 1 minus 2 2, then R3 plus R2 all will become 0. Correct na? Now see, this is in echelon form. This is in echelon form. But we want normal form na? If our problem is echelon form, we may stop here only, but we need normal form. So we have to continue to the normal form by changing columns. Okay, so continuation of the echelon form is applying column operations to convert these places 0. What all are we have to make the 0? I'll show you. Wait, see here, this is above the diagonal elements you have to make 0. This and this and here. These target, this we have to make 0. Okay, how to do it? We can apply column operations. First my target is this. I will make this. Okay, this and this and this. These 3 I'll make 0. How to 0? In the step 1. In the column operations I am doing step 1. In that case I have to take help from C1 only. I am expecting change in column 2, C2. C2 implies C2 minus C1, write down. Then C2 element is 1, C1 element is 2. Write down the coefficient for just interchanging only. C2 coefficient 1, I'll write for C1. C1 coefficient is 2, I wrote for C2. One more, I am expecting change in C3 also, column 3. Then again I will write C3 minus C1. C3 element is 3, write as the coefficient for C1, and C1 element is 2, write coefficient for 2 for C3, correct? Then I am expecting change in C4 also. C4 implies C4 minus C1. Then this is, see here, 2 0 0. 2 C2 minus C1, how it will change? 2 into C2, here see, 2 into 1, 2, 2 minus 2 is 0. Then again minus 2, right? 2 into minus 1, 2, this is 0, and here also 0 only. Again what I said, 2 into C3 minus 3C1, or automatically this will be 0 ma. Next, 2 into C3, 2 into minus 2 is minus 4, please write that, minus 4, and here also 0. C4 minus C1, 1 minus 2 is minus 1, 2 minus 0, 0. See how nicely it changed. Oh, see here what I did, C4 minus C1 I took. C4 element is 1, right? This element write for C1, but C1 element coefficient you have to write here na, 2 into C4. So then this will become 0. See, 2 into C4, see here, 2 into 1, 2, 2 minus 2 is 0 here, and 2 into C4, 2 into C4 means 2 2s are 4. 4 minus 0 is 4 ma. This is correct na. Diagonal elements again. A11, A22, A33. This is the diagonal elements. Now this is fine. These two is my target. I have to make this place 0. In the column first step, I need to take help from C1. In the second step, I have to take help from C2 only, right? That priority wise you have to take. Step 1 R1, otherwise C1. Step 2 R2, otherwise C2. Like that it has to be. Okay. Now see. C2, where I am expecting change now. My expectation of change is this place and this place. This is in column 3, this is in column 4. So I need to take help from C2. C3 change, C4 expecting change, C3 also expecting change. C3 minus C2, C4 minus C2, commonly write down. Then C3 element what? Minus 4 na? Column 3 element what you want to change? Minus 4. Please write that. And C2 element what? Corresponding element 2 is there. That write down here. And again C4 element is 4. Write down here. C2 element is 2. Write down here. That's all. Then how it will change? Expecting change in C3 and C4 only. So remaining elements write quickly. Then this will be 0 and C4 also will be 0 if you do these operations. Okay. Now see. Diagonal elements I need 1 only na. So make this C1 implies C1 by 2. C2 implies C2 by 2. Make this. Then automatically 1 0 0 0 1 0 0 0 0 0 0 0. This is identity matrix only na. Yes, it is identity matrix. How to write it? This is 2 by 2 matrix na. So I2 write down and all this 0 only. Just you make this. This is yours. And what is the rank for this? Number of non-zero rows are 2 here. So you can make it as rank is equal to 2. And I'll do one more problem. I think it is helpful if we do one more problem in the normal form. Okay. One more problem, note down. Reduce the following matrix to the normal form. Please write that. And I'll give the matrix. Reduce the following matrix into normal form. First row is 3 0 1 minus 6. Second row is all 4s are 1 only. Third row is 9 3 1 0 and fourth row is 0 minus 6 1 9. 0 minus 6 1 9. I am writing the matrix. See, 3 0 1 6 minus 6 here, and here all 1. If you able to do this problem, you are perfect in both echelon form as well as normal form, because half of the problem is nothing but your echelon form and remaining of is continuation with the column operations. Then see here, anyhow this is the numerical only, so we are happy for this, and better we prefer it has to be 1. Our calculation will be easy. Okay, so let me do that. Interchange procedure. R1 implies R2. Nowhere common multiples to cancel all, so 1 1 1, then 3 0 1 minus 6 I wrote, then 9 3 1 0 I did it, then 0 minus 6 1 9, right? This is our actual problem. You can interchange the row operations, no problem. Even column also you can do, but now not required for us. Okay, then this is 4 by 4 matrix here, square matrix. It's good. What is the diagonal element here? A11 element, A22 here, A33, A44. Perfect. Then our aim is we have to make this place 0, this place 0. Already this is 0, right? So no issue of this. Our aim in the step 1 is 3, 9. I want to make 0. For that, step 1. Let me take this color. Of course, this color also beautiful. In the step 1, I am expecting change in this R2. R2 implies R2 minus R1, write down. R2 element more what? 3, right? So write coefficient of R1. Then again, R3 implies R3 minus R1. Then R3 element is 9. 9 into R1. Then R4 is already 0. Not required to make anything. You understood, I think. If it is 1, this coefficient will be 1, right? Calculation will be easy for us. That's what I made this element as 1. All 4's ones, fine. Then we know that 3 minus 3, it is 0 only. Let me write it. See, I have the habit to do the rough work here. R2 elements what? This is the rough work in this color. 3, 0, 1 minus 6. Correct na? And R1 we are multiplying with the 3, right? Then 3, 3, 3, 3. If I subtract 3 minus 3, 0. 0 minus 3 is minus 3. 1 minus 3 is 2. Minus 6 minus 3 is minus 9. Correct na? This calculation, please everyone do it, because chance is there to get that mistakes. Generally I preferred calculator. R3 minus 9 R1. See here, in calculator also we can install that equation and we can write it. Okay, later I will explain that. Right, you concentrate in the method first. R3 elements are there na? 9, 3, 1, 0 here, and R1 elements anyhow all ones only na? 9, 9, 9, 9. Then 9 minus 9, 0. 3 minus 9 is minus 6. 1 minus 9 is minus 8. 0 minus 9 is minus 9. Correct na? Then R4 element, no change. 0 minus 6. 1, 9. Good. This is we got. Okay. Now see. Now what is our target? Again diagonal elements I have to make this. This is our diagonal element. And we have to make below the diagonal elements are zeros. These we made 0. In this step, our target is this. Correct na? In this step, change we are expecting in R3. Then you have to take help from R2. Step 2. R3 implies R3 minus R2. We can do it. But one more simple way you can convert, because this minus 6 na, if we are subtracting, then our work may be more simple. Let me try that. Okay. This is on the spot, depend on the problem you should take. If you don't have that idea, blindly whatever I am telling, like step 1 you have to take help from R1, step 2 you have to take help from R2, like that you have to. Anyhow, here the same numbers are there, that's what I am making this. I am adding that to. R2 implies R3 implies R3 plus not minus I will take. Okay, minus 1. Let me multiply with this. It's nothing but R3 minus R4 only na. R3 minus R4. Let me do this. 1, 1, 1. In the meanwhile, this step also I want the change. 0 minus 3 minus 2 minus 9. In the next step I will multiply with minus this. 0 minus 6 minus 8 minus 9. and this is R3 minus R4. So minus 6 minus of minus 6, 0. 1 minus of R3 minus R4. Oh, I am expecting change in R3 only. Okay, then let me do this. So erase this. This I will erase, and here. Okay, anything is fine for us. Okay, anyhow I told now I don't want to change it, that's all. And minus 6 of minus 6, it is 0. Minus 8 and R3 minus R4. Minus 8 minus 1 is minus 9. Minus 9 minus 9. Okay, minus 9 is minus 18. Beautiful. Then here minus 6, 1, 9. Okay. Then diagonal element, see what we have, 0, minus 3, and here minus 9, here 9. And our target is this minus 6 and 1. Minus 6 and 1 we have to make the zeros. Okay. For that, of course, it is little bit a lengthy problem. Simple problems everyone will do, right? Lengthy problems only, that help is required. That is the intention. I took the lengthy problem for you people. Anyhow, this is fourth and fifth problem, I guess. It's okay. So here I need to make this place as 0. Fine. For that, right, R1, R2, R3, R4. R4 implies R4 minus of R2 I am taking. Okay, R2, because all these all are zeros, right? And R4 element what? Minus 6 is there. So write for this. R2 element what? Minus 3. Write for R4. This minus 3 R4 plus 6 R2. This is okay, Nama. Then how to change? 1, 1, 1, 0, minus 3, minus 2, minus 9, 0, 0. R3 we are not doing anything now. Let me divide with R3 implies R3 by minus 9 also we will do. Then it will be 9 and it will be 2. Then 0 here. 3 R4. Rough work we will do. Rough work we are using pink. R4 minus 3 R4, right? 0 minus into minus plus 3 R4. 18 and minus 3 into 1 is minus 3 and 9 3s are minus 27. Then 6 R2. Then this is 0 minus 18 and minus 12 minus 54. Then if I add this, what it will happen? Minus 18 plus 18, 0. Then minus 12 minus 3 is minus 15. Then minus 27 plus 54. Oh my god, so much it came, na? Here minus, and 6 plus 4 means 10. No? 7 is there, na? 81 we got. Fine. The big problem. Diagonal element, here diagonal element, here diagonal element, here diagonal element. Okay. And now the target is this. We want to make that 0. Okay, na? If you want to make this 0, better to take the help from R3 only. This is an R4. So you can take that. Let me take this pin mode. R4 implies R4 minus R3 I will take. R4 element is minus 15. Na? So please write for R3. R3 is 1 only. So coefficient may not change for R4. Just interchanging these positions. That's all. 1 into 15, 15 into 1. Then what it happens? How it will change? 1, 1, 1. And anyhow here minus is extra, ma. please multiply with that. R2 multiply with minus 1, then 0, 3, 2, 9, 0, 0, 1, 2, and 0, 0, and anyhow this will be 0 only na, because R4 element minus 15 and minus of minus plus 15, this it is 0, and here and calculation last element is R4 element is 84 something is there na. R4 element is minus 81, then minus 81, R3 multiply with minus into minus plus here, 15 2s are 30, then minus 51, this is minus 51. Okay, see, now see the diagonal elements. These all are the diagonal elements. Fine, all the below diagonal elements are zeros only, and to make the simple, we don't want this much big number, let we do that divide with R4 implies R4 by minus 51. Okay, here anyhow then automatically it will change as, this is echelon form only. See how much time it took. This is the big problem, that's all. When you are checking yourself, you have to do this much big problems, then it will be anywhere. If you get the doubts also, it will be more clear to you. 1 1 1 1 0 3 2 9 0 0 1 2, then 0 0 0 1, that's all. Okay na, this is in echelon form. Of course this we have to make 3, but our aim is we have to convert into normal form, right? So we will continue, we'll make that by using column operations. We have to make remaining values are zeros. What all are the remaining values? See here, diagonal elements identify, 1 3 1 1 is there, and remaining all you have to make 0. Okay, see here, this we have to make 0. What is that? This first step, this is our target. So for that what we have to use? We have to use column 1 only. C2 implies C2 minus C1, C3 implies C3 minus C1, C4 implies C4 minus C1. You have to do that. Then 1 0 0, 1 minus 1 0, 3 minus 0 3, 0 0, again 1 minus 1 0, then it may not change. Why? Because here all zeros only na, same thing it will come. This is the way to do. Very easy, this column operations. Again, our diagonal elements are this. Then what is that? We have to make 0 in this step. First row, this first column, second column, third column, first elements we made 0. Now our target is these two we have to make 0. Okay, so for that, see, I'll do it. This we have to make zeros. For that, change expecting in C3, right? C3 minus, yeah, for your calculation purpose I want to do one more thing. That is, we'll do this, change expecting in C3, right? So we will take help from C2 only na. If we are expecting in change in C3, we will take help from C2, right? So let me make that element as 1, right? C2 implies C2 by 3 I'll do. Then 1 0 0 0 1 0 0, then 0 2 1 0 0 9 2 1. Correct na? This is good na? Now the next, after that, what all are the elements we have to make the zeros identify? Diagonal elements are here 1 1 1 1. Fine. Now the target is this 2 element, 9 element I have to make 0. For that, C3 implies C3 minus C2. C2 element is 1, C3 element is 2. That you have to write like this. C3 minus 2 into C2. Then again C4 element, this also I have to make 0 na. Then C4 minus C2. We are taking help this because already we made this 0, so we won't touch the C1. Okay, so this only 1 is here. Now see here, C4 element is 9, right, as a coefficient for C2. Then how it will change? 1 0 0 0 1 0 0, then 0. C3 minus 2 C2, C3 element is 2, 2 minus 2, 0 only na. 1 0, remaining it won't change. 0 here, 0 2 1. This is the calculation. And again, now the final target is we have to make this place as 0. All the diagonal elements are 1 only na. To make this 1, we have to take help from C3. So change expecting in C4, C4 minus 2 into C3. Then it will be like this: 1 0 0 0 1 0 0 0 0 1 0. C4 minus 2 into C3. 2 minus 2 0 only na. 0 0 1 0. See, this is your identity matrix I 4 by 4. It is in normal form only na. That's what, because the result of echelon form and normal form is same. That's what this method they avoid it. They are implementing only echelon form. Okay, normal form they are not using to find out the rank, because double work we have to do, right? You observe that echelon form we did 3 problems, normal form we did 2 problems only. By doing second problem only we felt restless, is it or not? And third method also there, just I'll give the hint to you. That also will help us to find out the rank, but comparatively normal form, that is the lengthiest one. That's what, that also they are not using. They may be using in programming, but in the examination, in that cases they removed that. Okay, if anyone have that syllabus, it may helpful for them. That's what I'm giving that idea about that. That is PAQ form. PAQ form. Any problem, if you are taking that, you have to write in terms of PAQ form. They will give the same problem only, like just I will write the problem. Find the non-singular matrices. Find non-singular matrices P and Q such that PAQ is in the normal form, and hence find the rank of A. And see, PAQ form, this is the method. And matrix they gave as 1 1 1 1 minus 1 minus 1 3 1 1. Okay, so the matrix A I can write like this na, I into A into I. Multiplication with identity matrix, I into A into I equal to A only, right? So how you can write the matrix A? I am writing, see, 1 1 1 1 minus 1 minus 1 3 1 1. This is then identity matrix here, right? This is anyhow 3 by 3 matrix na. That's what identity matrix also you have to take like this. 1 0 0 0 1 0 0 0 1. And A, and again here 1 0 0 0 1 0 0 0 1. This is 3 by 3 matrix. And this, now our aim is we have to convert the matrix A into normal form. You have to convert the matrix into normal form. Just we did na that. When we are using the row, when we are applying the when we are doing that normal form, we have to apply both row and column operations na. If you are applying row operations here, then this matrix will affect. If you are applying column operations, this matrix will react. You have to apply column operations on this matrix. You have to apply row operations on this. And this matrix you have to apply both row and column operations, and you have to convert into identity matrix. Okay, let me do one problem. Okay, if anyone have that syllabus, it may helpful for them. That's what I'm including, because these all are the 3 by 3 these all are the 3 methods which help us to find out the rank. Now our target is this is 1 minus 1 diagonal elements. I have to make these 3 places are 0. What will be the target? That I'll shade it. First my target is this. Then what I will do, R2 implies R2 minus R1 I will do. Correct na? 1 minus 1 is 0. Then again R3 implies R3 minus R1 I will do. R3 element is 3, right? Write down as the coefficient for R1. Then now change, see here how it will change. 1 1 1 1 minus 1 0 minus 1 is minus 2. One second, because this problem already that calculation everything R2 minus R1 I did it. That's what it may help us na. Fastly we can complete it. That's what 0 minus 2 minus 2, and even here R3 minus 3 R1 if I do 0 minus 2 minus 2, because video length will be more na due to that reason. What I said, I applied row operations, then first matrix will affect. I have to apply row operations for the first matrix. 1 0 0 is there, minus 1 1 0. If apply R2 minus R1, then R3 minus 3 R1 means minus 3 0 1 I will get. Then A I have to write as it is, and this matrix will be quiet because only row operations na. Whom I am asking the question, they only will reply. Other people may not write. Like that it is. If row operations, it will affect. Column operations means second one. Sorry. Now see here, after this identify. Okay, and in this one more beautiful what, 2 rows are identical, not required to identify anything first. This identical is there, now we'll make it as 0. For that what we have to do, R3 implies R3 minus R2 I will do. Correct na? Then what it will happens, 1 1 1 0 minus 2 minus 2, then this will be 0 0 0. Correct? Then row operations will affect. So 1 0 0 minus 1 1 0 minus 2 minus 1 1, because row operations means I have to do only here R3 minus R2, minus 3 of minus 1 minus 2 0 minus 1 1 minus 0. Then A into 1 0 0 0 1 0 0 0 1. Correct? Now again diagonal elements are here, these make 0, but our aim is we have to convert into normal form, right? So for that our target is we have to make these 2 places 0. For that what we have to do to make that, C2 implies C2 minus C1, C3 implies C3 minus C1. I have to do it. See here, if we are doing C2 minus C1, C2 elements will change. C3 minus C2. I'm writing here 1 0 0 same. I'll write C2 minus C1 na 1 minus 1 is 0, minus 2 0. C3 minus C1 na 1 minus 1 0, and it may not change anything. Now here see how it will change. 1 0 0 minus 1 1 0 minus 2 minus 1 1. We cannot change anything in this matrix. Row operations for this. Column operations I did na, so this will react. First column as it is I have to write. Second column C2 minus C1 they said. 0 minus 1 is minus 1. 1 minus 0 is 1. 0 minus 0. Again C3 minus C1 they did. 0 minus 1 is minus 1. 0 1. I feel that this is like a game. Then after that, what is the next aim for us? We are near to our answer. See, this place I have to make 0. Correct now? 1 0 0 0 1 0 0 0 1, like that identity matrix if I get. So this I want to make the 0. Just here minus 2 is there, here minus 2 is there. I can make that now. C3 implies C3 minus of C2. C3 minus C2. That's enough. Then 1 0 0 C1 is as it is. 0 minus 2 0 as it is. Then 0 0 0. That's all. Then this is the row. So no change in the first matrix. You have to write as it is. Correct? A into. And what is the next? C3 minus C2 here I did. So first column let me write 1 0 0 minus 1 1 0. Then C3 minus C2. Minus 1 of minus 1 is 0. 0 minus 1 is minus 1. 1 minus 0 is 1. See, almost it is identity matrix only na. What is the extra? Only that 2 element is there. Okay, 1 minute. 2 element is there na. In the second row 2 element is there. Minus 2 element. So let me divide with R2 by minus 2. No, I don't want to do with R1. Then you can do with the column C2 by 2. You can write C2 implies C2 by minus 2 also you can do. Then how it will change? 1 0 0 0 1 0 0 0 0. It is equal to, due to row it won't change. 1 0 0 minus 1 1 0, then minus 2 minus 1 1, and A, and this is called 1 0 0 column I will write. C2 by minus 2, right? Minus 1 by minus 2. It will be 1 by 2. Then again 1 by 2. Here 1 by minus 2. Then this will be 0. Then 0 minus 1 1. This is few places extra is there. I will remove. C2 by minus 2. Correct now? Minus 1 by minus 2 is 2. And again 1 by minus 2. It's correct. See here, problem is over. Column operations, second matrix will react. Row operations, first matrix will react. This is like a game, I feel. Of course it will be lengthy, but this is one of the method. This is also giving the answer. Whatever the method you are doing, rank must be same. That you have to remember. It may be the echelon, it may be the normal form, it may be PAQ form. If they not mentioned, just to find out the rank, then you can do any method. Among 3 methods, you can choose your own favorite method and you can do. But answer must be same. Okay. So what is the rank for this problem? Rank is equal to number of non-zero rows. How many there? 1, 2. This is only our hero. These are helpers for that. That's all. This is the matrix P and this is the matrix Q. P into AQ is equal to identity matrix. We got it. Okay. So this is your third method. And if you have any doubts, you can contact to me. And now in this lecture I explained applications of the rank and how to find out the rank by using the 3 methods: echelon form discussed, normal form and PAQ form. Echelon form means you have to use only row operations. Below the diagonal elements, you have to make 0. There is no like diagonal elements, it may be 1 or 0. Okay, try to make that either 1 or 0. Diagonal elements. Below the diagonal elements, it must be 0 only. Only row operations you have to apply in the case of echelon form. Whereas in the normal form, it's nothing but you remember like that. You convert into the identity matrix. You can apply both row and column operations. Okay, in the case of PAQ form, it is beautiful one. A is equal to P into A into Q. This A, LHS, whatever A is there, you have to convert into the normal form by applying both row and column operations. If you apply the row operations, RHS first matrix will react. If you apply the column operations, RHS, the last matrix will be there, that will be react. Okay, finally our rank is nothing but number of non-zero rows, that is equal to rank. Okay, and main applications, we are using rank to find out how many solutions we are going to get for the system of equations, and to know that whether rows are independent rows or dependent rows, otherwise whether columns are independent and dependent, and whether system is controllable or non-controllable, that we can do.